2030, 26% of all cars on the road will be electric. Current infrastructure, which is going into the ground, needs to last much longer. It needs to be installed once, but with the changing landscape of the future in mind. And it needs to eradicate legacy issues, such as congested footways, underground hazards, or long lead times for repairs. The knock-on effects of these are delays to civil works, spiralling costs, contractual disputes, and on-site damage. The fast-moving EV revolution won't have time to wait behind the trifling inconveniences so prevalent in civil engineering. NAL retention sockets have a lifespan of 100 years, which extends beyond those of current working methods. 99% of traffic signal posts in the UK are installed in an NAL patented retention socket. These are now ready to provide the means to connect any vehicle to mains electricity, at home, at work, and on the longer journeys we all have to make. NAL have a range of EV foundations for different types of vehicle charging: fast, rapid, and high-power charging. These allow essential charging stations to be installed anywhere and, more importantly, from any manufacturer in any country in the world. For domestic roadside charging up to 22 kilowatts, the fast foundation is ideal for this kind of overnight charging. The socket head and duckfoot bend both swivel independently through 360 degrees to allow ducting to feed in from any direction. When setting in place, concrete only needs to be poured once, allowing space for paving or tarmac to be laid on top. If required, the retention socket can be precast into concrete blocks before it arrives on site for faster installation. In either case, the socket remains safely sealed in the footway until equipment is ready to arrive on site. To install equipment, the side chamber is raised to allow access to the main socket chamber. Cables come up vertically rather than at an angle with most current methods. The duckfoot bend below allows for a wide cabling bending radius. One feature unique to the fast foundation is that the cover can be stowed in the side access panel for future use, safely securing it in between equipment installations. Once installed, charging units can be replaced or upgraded with little inconvenience to the public, compared to traditional methods which can require road closure and a civils contractor. For more rapid charging units up to 150 kilowatts, such as in places of work, the rapid foundation is used. This is a shallow foundation unit, meaning it can be installed where present amenities restrict deep excavation. The rapid foundation has 4 150mm duct access points that allow duct entry from multiple directions and allow easy access for cabling to come up vertically into the charging unit. The 4-way access ports make it easy to link to other chargers, and the foundation is also set in place with concrete. The rapid foundation works with a multitude of adapter plates to suit different charger units from different manufacturers. This future-proofs the feeding of power to new units which have yet to be designed. Adapter plates are safely eased into position with the help of lifting loops. Adapter plates mean there is no civils downtime waiting for specific manufacturer fixings, and the civils work can be done once, with the charging unit coming later once it's ready. Locating pins are fitted across all 4 corners for smoothly lowering the charger unit into position. The composite socket can accompany this medium-sized socket for the installation of protective X-last bollards and comes in a non-conductive composite material for safety. Plus, the smaller RS76 retention socket allows for the installation of non-illuminated signs. For high-power charging, for power ratings of 150 kilowatts and above, such as filling station forecourts, the award-winning high-powered charging foundation solution is used. First, the area is excavated and levelled with a base of compacted material. Then, the sections of the stacker box chamber are assembled using nothing more than a simple rubber mallet and then levelled. It can also be easily core drilled to make way for the ducting. For efficiency and future planning, this method allows multiple units to be installed to prepare for increased demand in the future. The top plate is bolted to the stacker box, and then the high-power foundation is bolted in place. For certain EV charging units, a separate duct is required to route the cabling. The chamber unit is easily adapted to accommodate this addition. For EV charging units, which require a larger hole due to cable size and positioning issues, the stacker DAPT plate will overcome these problems. The area is backfilled and compacted before being topped off with concrete or chosen finished surface. As with the Rapid foundation, protective bollards and signage can be installed and then easily removed for quick installation or maintenance of charging units. When equipment is ready to install, the socket and the chamber below enables the easy passage of larger cables, which require a greater bending radius. Again, with the right adapter plate for the job, this system is compatible with any charging unit, ready for whatever equipment innovations the future may bring. Wherever the location or power requirement, NAL EV foundations are perfectly suited to any location and provide the solid foundation for enough power to keep everyone moving. The NAL retention socket will still be around in 2040, when 72% of all cars will be electric, and still around in 2050, and in 2060, and beyond.